Okay, so I got 53 minutes to do this presentation. So I'm going to take my time with it and get through everything, okay? Now, first, let me start off by telling you what Hemp Paradise is. Hemp Paradise is an industrial hemp and manufacturing company that I'm building and I'm currently raising money for. Later on, I will show you the GoFundMe. But first, I want to go over, that's what I want to take my time about, and go over exactly why it is needed right now. Why did I choose industrial hemp? So first, I'm gonna go to YouTube. If these words type in right. Okay, and I'm going to explain to you exactly what global warming is because it is my understanding that not a lot of people really know about it and understand the urgency. So, okay, so let me explain to you about global warming. First, that is carbon and methane. Let me break it down real quick because this is taking a long time to come on. Um, Carbon and methane are the two top things that is causing the globe to heat up. And now, this has been known about since the early 1900s, okay? About the time of the Industrial Revolution, over the decades, there has been scientists warning about global warming coming, but it's been put off. It's been put off and put off and put off, okay? Politicians didn't believe it. People just didn't want to believe it. So by the time Industrial Revolution, with industries, in particular petroleum, being burnt off, different coal and chemicals from manufacturing companies, harsh chemicals from certain manufacturing companies being burnt into the air, forest trees being burnt down, with the production of plastic, and that being burnt because it takes over 400 years for plastic to break down. It's pretty much not biodegradable, okay? Because it takes so long to break down. So it's burned, it's melted, it has to be even burned to be recycled. And all of that is putting carbon and methane into the air. So then there is also overbreeding and production of cows. The methane gases that comes from cow farts. The carbon and methane that is put into the atmosphere from these farms is adding to global warming. Okay? So we go watch this. I actually want to go to an expert.
Climate change is expected to have a big impact on agriculture. We've seen temperatures rising at a rate of about 3 degrees per century for an annual average. We also see that nearby ocean waters have been warming, and there's a lower frequency of snow and ice happening, especially during the spring season.
Okay, there's actual changes. We're actually seeing changes.
And elevated CO2 levels. Since we have a large coastline here, we're seeing effects of sea level rise.
There's evidence from much of the world that the heaviest rainfall events are becoming heavier. We also expect that as the climate warms, we will see greater
Let me cut the music down, make sure you can hear this.
particularly during the summer months, and a greater frequency of heat waves and less frequent cold spells. It's not simply working your way past an unfortunately timed drought or a cold spell. It's more systematic than that. It's something that we have to deal with, not just once or twice, but on an ongoing basis.
If you're growing a crop like corn or like tomatoes, it's an annual crop. You can plant something different the next year. Planting a perennial crop, you can't really do that. If you're growing a crop like blueberries or grapevines that are going to be in the ground for 30, 40 years, and you have to be thinking about what is the climate going to be like as we go along, and how is it going to affect the longevity of my crop.
Extended periods of hot weather can be a problem. There's heat stress on the plants.
I hate how slow this moves and how I don't type all the letters when I type it. Okay. Minutes, 2 minutes. We're going for a quick video. And now I was looking at a video earlier with a brother showing about global warming. Anthony Browder talking about global warming. Why is this set not sound?
Fighting climate change may feel too daunting for any one person to take on, but a recent report shows that if enough of us change our behaviors and promote change in our communities, we can reduce global greenhouse gas emissions by as much as 37% over the
If we all change our patterns. If we all change our patterns. Okay? There's things that can be done.
reduce global greenhouse gas emissions by as much as 30%. But a recent report shows that if enough of us change our behaviors and promote change in our communities, we can reduce global greenhouse gas emissions by as much as 37% over the next 3 decades.
If enough
Here are
of
some
us
the
change our
changes we can
patterns.
make that will have an impact. While individuals can't revolutionize the shipping, flight, and automobile industries overnight, we can make sustainable choices every time.
Right. So, we can't revolutionize it. We don't own those companies. But we can start companies. We can purchase from companies that are sustainable. Okay, let's
Then we need to go somewhere. Public transportation, carpooling, biking, and walking are all great alternatives when feasible. For a bigger impact, choose.
And now, the reason for this is because of gas. Burning fossil fuels. We use fossil fuels for gas, we use fossil fuels for the oil to lubricate the engine, and all of that burns off and is going into the atmosphere. So another thing that they talk about is electric cars. Okay, electric cars are a thing now. The government is putting money into electric vehicles, but not everybody can just go out and purchase a vehicle. That's why hemp paradise. Okay, alternatives, biofuels, but we gonna get into that later.
A fuel-efficient vehicle when purchasing. Powering your home with solar or wind is still one of the best ways to fight climate change.
Absolutely.
The good news is that solar panels are becoming increasingly more affordable across the world. Another way to help is to make your next stove, water heater, and furnace purchase electric rather than gas. If these are not feasible options, switching all light bulbs to
electric, and I can pull that up too. The electric companies also use fuel. They're using fossil fuel to help get that electricity to you. There is some fuel being used, which is also why hempcrete is a beautiful thing, because it actually saves in the power bill. So that means using less of the electricity that is using fuel to burn it. We'll get into that too.
LEDs, unplugging electronic devices while they aren't in use, washing your clothes in cold water, and cleaning or replacing your HVAC filters every 3 months are small ways to help. After fossil fuels, the food industry, specifically the beef and dairy sectors, is one of the biggest contributors to climate change. If cattle were their own nation, they would be the world's third largest emitter of greenhouse gases after China and the US.
Because they're overpopulating it. It's not just because of the cows itself, because cows was already here and cows was never an issue before. It's because of how they're being bred, packed into meat houses, ready to be slaughtered or to be milked until they die. Okay? It's because of the overbreeding. Because people need to make money, keep pushing it out, overconsumption. Okay?
Vegetarian to make a difference. Reducing your beef consumption or using dairy
There we go,
alternatives are ways to help reduce this impact. Not only do small actions like these add up,
less, they
social
breed
scientists
less.
have found that when one person makes a sustainably oriented decision, other people do too. And as we all know, climate change won't be solved by individual habits alone, but will require broad policy solutions from governments, nonprofits, and industries around the world.
This is why it's important when you vote to hold the politicians accountable to this. Make sure that they got this on the agenda and hold them accountable. It actually makes a difference. And now, what is global warming? Cause and effect of climate change. And now I actually want somebody to break down and explain exactly what it is, showing exactly what's happening, what's causing it to heat up. So I'm looking for that good video. And there was one that was a really good explainer. Let me go back to my history, because this doctor's channel, there's a Nobel Prize winner who is talking against global warming, and she does a really good job at breaking down why that didn't make any sense, what he was saying. Okay, one of the big things is he was saying that clouds suck up all the carbon and create
Yesterday was amazing. After surviving a life-threatening respiratory virus,
and
Bruce
cools
took
it
steps
down.
to protect himself from an
or keeps it pretty stable, keeps the carbon in the atmosphere pretty stable. And that's not exactly true. It is heating up. The more it's in here, the more it heats up. It's not releasing it into the atmosphere. And there's still carbon being burned. Citibank, there was just a group of elders the other day that protested Citibank and ended up getting arrested. A group 60 plus, and they are the same group that's responsible for starting Earth Day. Hold on, let me find this video. And anyway, they're protesting Citibank because Citibank just funded new oil production, not the same ones, but funded the companies to go and dig for more oil and set up more oil drilling plants. Billions of dollars invested. Shoot, I wish I could remember the name of the video. It's coming. Just wait. Thank you for viewing this video. Thank you for staying with me. This lady is pretty funny too. Come on now. Time to get real about climate change. That was like a oh no. Okay, this is awkward. Well, this is awkward. Climate myth. Here we go.
Attention retirees, if you're willing to be at your computer from 9 a.m. to 10:45 a.m. on most weekdays.
Just in case you wonder, memma is the Latin word for.
Attention retirees, if you're willing to be at your computer from 9 a.m. to 10:45 a.m. on most weekdays, I can show you one simple trade that could potentially bankroll.
John F. Clauser won the Nobel Prize in Physics 2022. A few months later, he came out as a climate change denier. He believes that climate change is a total myth.
I believe climate change is a total myth.
Oh dear. Clauser just recently gave a talk at a conference in which he explains that climate scientists are, quote, clueless and dishonest, and why he's the only one who can correctly calculate how the Earth isn't warm. So grab some popcorn and let's go. The entire talk is 18 minutes long and about half of it is the word okay. So I hope you'll forgive me if I just give you the brief summary. You can watch the entire thing on YouTube if you really want to. John F. Clauser, JFC, begins his talk with the radiation imbalance of Earth.
So if we have more power coming in than flowing out, there's a buildup of energy. And that is actually the definition of global warming.
Really? That's the IPCC definition of global warming? Why would they do that? Let's check. The IPCC report says
global warming refers to the change of global surface temperature relative to a baseline depending upon the application.
so. The premise of his entire talk is wrong. Not a great start. It'd be crazy for the IPCC to define global warming like Klaus said. You see, our planet gets radiation from the sun. Some of that gets reflected by clouds and some hits the surface. The light that hits the surface is converted to infrared. That gets partly trapped by carbon dioxide, which keeps our planet warm. As long as the carbon dioxide concentration is stable, the energy that comes in per time is the same as that which goes out per time on average. This is what's called the radiative balance. If we increase the carbon dioxide level, that means our atmosphere retains more heat than previously. So less goes out, and that leads to an imbalance. In response to this, the planet warms. That's where global warming comes from. However, there's no simple relation between the temperature change and the radiative imbalance. Indeed, the imbalance can be arbitrarily small, regardless of how much warming there is. The easiest way to see this is to imagine that we increase carbon dioxide levels very, very slowly so that the temperature can adjust along with it. In that case, Earth remains very close to equilibrium, almost exactly balanced. Indeed, this is probably what happened when carbon dioxide levels on Earth fell and rose naturally. Since we are pumping out carbon dioxide very quickly, we expect there to be an imbalance. However, since the relation between the radiation imbalance and temperature increase depends on several other factors that are not very well known, and the imbalance is hard to measure in any case, it makes no sense to use the imbalance to define global warming. What this means is that...
Okay, so global warming is about the temperature, not the imbalance, but the imbalance is causing a rise in the temperature, okay? They may not know exactly all of the factors that is going into the imbalance, and one recently that they had not taken into consideration before is the lakes drying up, okay? The water holds carbon. Water is the number one thing that holds carbon, okay? It's in the oceans, and the seas, and the large lakes. And now as the lakes dry up, I spelled that wrong, but I'm glad it's still, Salt Lake is drying up and it's releasing more carbon into the atmosphere. They did not take that into account before. So that is increasing the temperature of the globe. How they test the temperature, they used to use satellites, but that wasn't very accurate. So they switched to NOAA uses water. Use the water
Great Salt Lake is drying up, and as the majestic lake slowly but surely
to test the temperatures of the water.
There's major concern not only for the wildlife that relies on the lake, but for people living in Salt Lake City and what it might mean for the air there. Arcana Whitworth files this in-depth report.
Great Salt Lake, the largest saltwater lake in the Western Hemisphere, and the 8th largest freestanding lake in the world. But what used to be Whalers' Paradise and a safe haven for wildlife is now a leading ecological disaster. Climatologists blaming unrelenting high temperatures and a record western drought made more severe by climate change, being blamed for the lowest water level ever seen in Utah's Great Salt Lake. The lake now just 1/3 its usual size and shrinking weekly.
It's a little deceiving. This looks like a lot of water, but in fact, I'm standing in just a few inches of water. And under average lake conditions, I would be completely submerged, and you wouldn't be able to see any of this land surrounding me. Instead, 2/3
This
of
is
the
how
lake
much
bed
is
has been
drying up due
exposed.
to global warming.
That's nearly 800 square miles of salt.
Is there what kind of health problems could they experience?
Well, respiratory and cardiovascular, if you're compromising on any of those fronts, it's just going to be worse. The particulates
In the air.
in the air.
See, this is what's
For
happening.
Salt Lakers over the last several years, the area is prone to dust storms that could have the potential to be hazardous for the state's most populous city.
There's lots of toxic minerals, but the one that will capture most people's attention is arsenic. In the wintertime, we get what's called winter inversions, traps any particulates.
In the air.
In the air,
Yeah, it's like putting a lid on. Kind of,
exactly. As our winter storms come through and whip up some of this toxic material, i.e. not arsenic, plus many others actually, that's going to be deposited over into the water circulation.
You're telling me that
See, did you
if
see
the
that?
lake bed is dry during
The
a
wind
winter
is
storm,
blowing arsenic and
things
other
like
toxic
arsenic
chemicals.
could be in the air for anybody in Salt Lake City
Right.
and surrounding areas.
Yeah, and trapped.
And surrounding areas.
People that live there, what kind of health problems could they experience?
Because you have to remember, plants, gases, they don't care about man-made borders.
It's just going to be worse.
There is no such thing as leaving the U.S. to escape global warming. It's global warming for a reason. It's happening all over this planet, all over the globe.
For years. Under his guidance, farmers and ranchers who use 65% of the area water to produce the state's top commodities, like livestock, hay, and grain crops, are making small changes with a big impact.
So that's called drip tape, and it's a little hose that gets buried, and what it does is it just pushes on up a foot. This year it only went up a foot. So it's going to go down 2 to 3 feet. That's why we keep hitting these record lows. And the problem is it's a shallow lake. There's not many more feet to go.
He says conservation alone won't be enough. They're looking at generational investments from the state and federal government.
Can they save Great Salt Lake?
They will have to.
And Lindsay, those airboats we were on were the only boats we could use to get out on the water because they can operate in just a few inches. Because as you can tell, this is what a lot of the lake looks like. I'm actually walking right now in the Antelope Island
That's what
Marina.
used to
So when
be
you look back here, you
the
can
lake.
see all of these empty boat slips. Now, they actually had to take most of the boats out of the water last year, and this year has been the third driest year in state history. And so that is forcing leaders to say things like conservation alone is not enough. They have to consider drastic measures like piping ocean water in to save the Great Salt Lake. And Lindsay, they think it could work because we have to keep in mind the Great Salt Lake itself is actually 5 times saltier. Welcome back to this U.S. Open office plant.
Miller just laughed at us
Okay,
way over
so
Jones
now
using some technical jargon.
Thanks to Curiosity Stream for
hopefully this is the video that shows the cycles. The last time it was the global warming.
teeming with life, trees, insects, pretty little birds. Primates are climbing up in the canopy while crocodiles and turtles swim in the rivers below. Beautiful, isn't it? Now imagine this lush rainforest in the Arctic. There was a time, not too long ago, when the world warmed more than any human has ever seen. So far, this ancient warming took place over the course of just 200,000 years, the blink of an eye in geologic time. And it ended much like it began, suddenly and mysteriously. It all started 56 million years ago at the very end of the Paleocene epoch. Back then, life was still recovering from all the unpleasantness of the Cretaceous-Paleogene extinction event, which wiped out the non-avian dinosaurs, and things were already warm by today's standards. There were no polar ice caps, which meant sea levels were much higher, and the continents, which were just beginning to take a familiar shape, were covered in habitats like temperate forests, deserts, and a belt of rainforests around the equator. But this environment was about to change. In fewer than 20,000 years, the global average temperature increased by 5 to 8 degrees Celsius, and the warming was greatest in higher latitudes. So So at the poles, temperatures on land reached an average of 23 degrees Celsius, while the ocean waters got up to a balmy 20 degrees. This means you could have gone for a comfy swim in the seas around Antarctica. This remarkable and sudden warming event is known as the Paleocene-Eocene Thermal Maximum, or PETM, and it had a massive effect on life on Earth. For one thing, when the PETM reached its peak, rainforests had expanded much farther than they ever had before. Fossils from North America, Europe, and Asia reveal habitats rich in plant life that are today associated with tropical rainforests, even though these forests were nowhere near the tropics. The fossilized fronds of palm trees have been found as far north as Wyoming, for example, and some places within the Arctic Circle, like Ellesmere Island in Canada, show evidence of ferns, redwoods, and ginkgos. So, how was any of this possible? Our best clues can be found in ancient sediments. Marine sediment samples from Maryland to Antarctica show that about 56 million years ago, there was a sudden spike in the amount of carbon dioxide and other greenhouse gases of the oceans. Judging by the types of carbon found in these sediments, these gases likely came from organic matter, like plants. See, plants, like most living things, prefer to use the lighter and more common isotope of carbon, carbon-12, as opposed to the heavier isotopes like carbon-13.
Okay, so those are the natural global warming cycles. Now let's hear why what's going on right now is not a part of the natural cycle. And it's because it's heating up a lot faster.
So here's the deal.
Due to pollution.
Forces influence climate change. This has been true throughout Earth's history. It's still true today. Climate scientists know this. In fact, it is by studying these natural.
So when climate scientists say that it's an issue coming, it's a real issue coming. And they've been saying it, and it's only gotten worse over the years, not better.
Natural cycles, they discovered most.
It's happened a lot sooner than the natural cycles. This is very unnatural and man-made, this global warming.
This is important because even with all of these natural ways to change the climate included, the only way to get climate models to even come close to what is actually happening is to add in all the stuff that humans are doing to the climate too. In other words, natural forces cannot account for the speed and scale of climate change since the start of the Industrial Revolution, particularly from the second half of the 20th century to today. To explain that, we have to add one more factor to the equation, us. So here's what we're going to do in this video. We're going to talk about the big picture of Earth's climate and how, when certain things get out of balance, Earth's climate warms up or cools off. Then we're going to unpack a bunch of those natural forces, again, that scientists know a lot about, that push Earth's climate one way or the other. And finally, we're going to explain how exactly we know that what's happening to Earth's climate today and into the near future isn't due to those natural forces, but rather is our fault. So, Earth's climate, how that works? Well, it's complicated. Fully understanding the thermodynamic Rube Goldberg machine that is the climate is more appropriate for the scope of a full university-level course, not a single YouTube video. But the part of Earth's climate we're most interested in is temperature. Temperature is essentially just a measure of how fast something's atoms are jiggling. More jiggliness means higher temperature, less jiggliness means lower temperature. You might also know that when something is jiggling a lot, it has more kinetic
jiggling,
energy.
moving around, or frequencies.
You see, something doesn't have heat. It has energy. We can think of heat more like energy on the move from someplace over here to, I don't know, someplace over there. When we heat something up, what we really mean is we've moved some energy into that system, which can make its stuff jiggle more, which raises its temperature. Sometimes the thing we've heated up can give its energy to something else and heat it up, and so on and so on. Well, congrats! Now you know enough thermodynamics to figure out global warming. So Earth's temperature begins here. A gigantic ball of jiggly stuff called the sun. Energy from the sun, aka sunlight, takes a roughly 8-minute trip to Earth where right off the bat about a third is reflected back into space by bright stuff like clouds and ice. But most of the rest is absorbed by the land and ocean, a small amount is absorbed directly by the molecule in the atmosphere. All of this
And by the land, that's meant the land itself and the plants, vegetation.
it basically makes all of Earth's atomic stuff more jiggly. But as all that stuff, rocks, air, oceans, warms up, they can transfer their
Spoiler
heat to
alert.
other stuff in the
Hemp
form of thermal
is the
infrared
#1 sequester of carbon.
You know,
Absorbs the most carbon.
So as land, for instance, gives off energy it originally got from sunlight, that energy zips up into the atmosphere where it's absorbed by water vapor, other gases like carbon dioxide and methane. But this is also where things really start to warm up, because these are those greenhouse gases you've heard so much about. And they're special because when any of that energy that Earth absorbs and then re-releases hits a greenhouse gas molecule, it can suck it right up and re-radiate it, warming the atmosphere and the land and the ocean and everything else. It's just like how bricks in a pizza oven hold on to heat and slowly radiate it out so it can be absorbed by that delicious bubbly cheese that you're gonna burn your mouth on no matter how many times you promised yourself you learned your lesson last time. This absorbing and re-radiating of heat by the atmosphere is the greenhouse effect. And just like your favorite dab on hot ones, it can actually be a good thing as long as there's not too much of it. Because if we had no greenhouse effect, the average temperature on Earth would be more like minus 18 degrees Celsius instead of the comfy 15 degrees Celsius that it is today. In other words, we live on an ice planet, or not live, more like it. Of course, on the other hand, if there's extra greenhouse effect, like, say, from the addition of a bunch more greenhouse gases to the atmosphere, then you get, well, what's happening today. The planet gets hotter. The air, the land, the water, all of it. And like the little domino in that one beam, what seems like a tiny change here to Earth's temperature, down the line can mess up some pretty big things. Wind, ocean currents, precipitation, you name it. This finally brings us to that title card put up at the beginning of the whole section of the video. Big picture, you can think of all this energy transfer from sun to land and ocean to the atmosphere, back to land and ocean, and all the little energy swaps in between.
Alright, so you get the gist of that. You can go to that video, The Biggest Myths About Climate Change, and finish watching that. So now, is there a tipping point? Is there a point of no return? Yes, there is, and let's talk about it. Okay. What the Earth will look like when these 6 tipping points hit. And this is perfect because I wanted to show all the different disasters and the predictions also. This video was put out a year ago.
Really that big of a deal? How about 2? Could 1.5 or 2 degrees of warming from pre-industrial levels mean doomsday or game over? Seems kind of extreme, but we know that the Earth will look different as the climate warms because we can already see some of it happening around us. And there are some pretty amazing models that predict what the world would look like, changes set in motion by just a bit more warming. So who's going to be affected? Where will we feel the effects first? And how can such a small change matter in such a big way? The answer lies in understanding tipping points. But when will we reach them?
In the early 2000s, the kind of general consensus would have been maybe we're at risk of tipping points at, say, 4 degrees C of global warming, where now we're just publishing a study which essentially says exceeding 1.5 degrees centigrade in global warming and about the industrial risks multiple climate tipping points.
And that's very close to our current level of about 1.1 degrees of warming. So let's find out what the world would look like if we hit 6 of the 15 most pressing tipping points identified by the International Panel on Climate Change. First, we'll explain how changes that could be set in motion very soon would fundamentally change our world. And stay with us until the end when we see just what the Earth would look like if we tipped.
So there is a tipping point. It's 1.5. We are at probably like 1.3 right now. This was a year ago at 1.1.
Won't change much, but if our director is leaning back in the chair, precariously balanced, and adds just a tiny degree more leaning, the chair reaches its tipping point and suddenly falls until it finds its next stable state. And this is essentially
That's
what's
what the tipping
happening
point
to our
is.
planet's climate. Many of our planet's systems getting precariously close to sudden, potentially irreversible change. We'll begin our journey all the way up in the Arctic, which is warming about 2 to 3 times faster than the rest of the planet. This is because as global warming melts the reflective white sea ice, more and more of the dark blue ocean below is revealed, which absorbs energy from the sun, further warming the region. That gets us to our first tipping point.
We're seeing accelerating melt of the Greenland ice sheet because of that extra Arctic heating.
It's not just darker water absorbing warmth from the sun. As Greenland's ice melts, it exposes land which heats up faster than the more reflective ice and water around it, speeding up the melt by 60% according to
Already because of the warming, coral reefs are being bleached and dying. That means the animals that lives inside the coral that gives it its color is being kicked out because of the change in temperatures. And then the corals cannot survive and they die. And the animals that live in them cannot survive without the corals, so they also die. The fish and other life that uses the coral reef for survival, they are also dying.
That poses a risk for what's called the Great Overturning Circulation of the Atlantic Ocean.
This is commonly referred to as the AMOC. It's essentially a giant flow of water that acts like a global conveyor belt, bringing heat from the southern hemisphere all the way up north to Greenland.
Under normal surface, the water gets cold enough and salty enough and dense enough to fall from the very top of the ocean all the way to the bottom in a process we call deep convection in the seas either side of Greenland. But if you have fresh water pouring off the Greenland ice sheet, you make the surface waters fresher, less dense,
Okay.
less prone to sinking to the bottom of the ocean.
And then you can finish looking at that to see
Factor
what happens.
observed weakening of this great overturning of the Atlantic Ocean.
Some calculations show that the AMOC is already weakened by around 15% in the last 8 years. And
Alright, so they use a tub model to explain about CO2 and the changes and exactly what's going on and where we are now. This one is 9 years ago. I wanted one that was more recent. But since I was taking too much of my time. Is this the one we would go to a year ago?
With the world in chaos, what's really needed is someone to finally make sense of human seemingly.
Do you think this video will be on the internet in 2070? Maybe in some internet archive somewhere? Well, researchers of the future, if you were wondering what we were doing here in the 2020s about climate change, the answer is we were committing to net zero. In the past few years, more than 70 countries, one after the next,
So they're talking about the
have made
Paris
a pledge to
Agreement.
reach net zero emissions. That includes places that have barely contributed to planet warming. And it includes
Because it affects
all of the
everybody.
countries that have been most responsible for emissions so far.
U.S. and China being the number one contributors.
Humankind needs to become carbon neutral, and we need to do it in the next 3 to 5 decades. But that would have been easier if we had started cutting emissions 20 years ago, because now we're up here, and the math is getting really tough. So to make it work, governments are
Or
penciling
even
in
50 years ago, or even sooner, and never started.
zero promise, the idea that we should reach zero while still
Actually went forward and supported the hemp car instead of supporting fossil fuels.
a lot about it. It's called CDR, so carbon dioxide, where people, what we want to do is put that carbon back where it belongs. Gianna Amador is a CDR advocate. She's going to help us explain this with the bathtub metaphor. bathtub in this situation is our atmosphere, and the water in the bathtub is the CO2 that's in our atmosphere.
Before the Industrial Revolution, the land and ocean typically released as much CO2 into the air as they absorbed back down through this drain. But when people started digging up coal and oil to power their machines, first in Europe and then in the US, it sent this new flow of CO2 into the air, one that the plants and oceans couldn't keep up with. About 45% of those emissions stay in the atmosphere, trapping heat and setting us up for an escalating array of climate disasters. So in 2015, all of the countries sent someone off to Paris to say, okay, everyone, we need to keep warming well below 2 degrees Celsius. And really, we're aiming for 1.5 degrees. That's above pre-industrial levels. And the exact numbers matter less than the fact that every increment of warming increases risk.
So first and foremost, we need to turn off the tap. Everything else is futile if we don't solve the root of the problem today. Turn off that tap, stop emitting CO2.
Not only have we not turned off any taps, global emissions are still rising, especially in Asia, where 60% of human beings live, many of whom are just emerging out of poverty. So now we're here at nearly 1.2 degrees of warming. Frankly, we have not done what it would take to meet that 1.5 degree goal. But we may be able to keep warming under 2 degrees if all of those net zero promises become real net zero policies. And that's where things get a little tricky. Turning these emissions all the way off could get really hard, really expensive, or even unfair. So everyone's kind of hoping that we can work from the bottom of the tub too.
Should kind of increase the size of the drain, increase the speed at which we can drain that water from the bathtub.
Now CDR is distinct from CCS, which prevents emissions at the source. That works on the faucet. CDR...
Now, carbon capture is those big machines that they have that captures the carbon, turns it into a liquid, into a solid. But what do they do with that carbon? They don't put it into the ground. They don't put it back into the ground. Companies are burning it off. So that means that more is going into the tub, okay? In this metaphor, they use water as the CO2. More water is going into the tub is the atmosphere. More carbon is going into the atmosphere. Okay, one of the things they say land and ocean. Here is also hemp. Plants, trees, all the vegetations that eats carbon dioxide, breathe in carbon dioxide and breathe out oxygen. Okay? So, let's finish this real quick.
CO2 from the air. And people have come up with a lot of interesting ways of doing that. The most common one so
Beautiful
far
stuff.
is planting and protecting forests. It's one of the more affordable CDR approaches
Trees.
right now, and it has a lot of benefits aside from capturing CO2. But we've seen from problems with the carbon offsets market that it can be hard to verify. And, trees don't live forever. So most of the modeling scenarios that limit warming assume we'll also be able to build a new drain for more permanent carbon storage.
So through things like rock weathering, we can push up a bunch of rocks that naturally react with CO2 and try to speed up that reaction. Or we can use chemistry to mimic natural processes through technologies like direct air capture, which basically use a type of chemical that selectively binds with CO2 to capture it from the air.
These techniques all come with different costs, and they're in really early stages of development. So there's a concern that the people in charge of the faucets will see any movement down here as an excuse to avoid making cuts up there.
Right, which is bad, but guess what?
Climate plans? Well, it seems we already are. The U.S. government's net zero plan calls for 500 million metric tons of CO2 removal by 2050, up from zero today.
Okay, so we need the policies in place. All right. We need the policies in place telling companies that they cannot burn fossil fuels. They're not adding to the carbon.
To establish your business using an address other than your home? Wish you had a professional.
And we also, in addition to not producing more carbon in the atmosphere, we need to suck the carbon out of the atmosphere. The hemp plant is the #1 sequester.
A plant that grew quick and tall, that dug its roots deep into the dirt and sequestered tons of carbon back into the soil while...
And just like trees, like she said, the trees die, hemp plants also die. But the great thing about hemp plants is that you can make so much with them. You can leave the trees there to also sequester the carbon. Trees also seed clouds and are responsible for natural weather patterns, rainforests, habitats for animals, and all of that good stuff. You can leave the trees there. The trees take a long time to grow. Carbon sequesters the same amount as trees do in the tree's entire lifetime. Carbon sequesters that amount in one grow. You can chop those down, use it to make products that are healthy and non-toxic, and grow more hemp. So you're getting 2 grows a year, and it's growing every year, as opposed to one tree that takes several years to reach maturity.
Metals back out of it. Could you guess what it is?
It's also cleaning up the soil and groundwater.
For its association with its cousin, wheat. That's right. This miracle plant is hemp, but in the U.
And they say cousin, but it's the exact same plant. It's literally the exact same plant. It's the exact same plant. Okay? Legal purposes, like physically, biologically, it's the same plant. Legal definitions, the same cannabis sativa plant that in maturity has not produced more than 0.03% THC is considered hemp. And now it is damn near impossible to predict and to get that right now, although there are people, especially breeding hemp seeds or cannabis sativa seeds, to not produce large quantities of THC. But the federal government, is part of the law, the federal government is stating that a remedy for it, if you have to get your test plan, no matter what state you're in, you have to get it tested. And if it tests over the limits, you do not have to destroy your entire crop. You can cut the flowers off because they're so fearful of this medicine, okay, of the flower of it. They say that you can cut it. So that means you can still use the fibers. You don't have to destroy the fibers. The fibers can still be used for hempcrete, for clothes, for pet bedding, for all sorts of stuff. Okay? And when you mix hemp with lye to make hempcrete or hemp lye, as some people in the industry call it, it is actually still sequestering carbon. So you have your buildings made out of it, sidewalks made out of it, bridges made out of it, because it is very strong. Okay, the structural integrity, it may not be the same, but there's ways that architects can build with it, and it's very safe, and it's actually still sequestering the carbon, making it carbon negative, not even just neutral. Negative. Carbon neutral means not putting carbon out into the atmosphere. Carbon negative means pulling carbon out of the atmosphere, much more carbon out of the atmosphere than is required to grow it.